Hi Year 12s. This is a review video to explain how to sketch more advanced polynomials. A degree 1 polynomial is a linear function. A degree 2 polynomial is the same as a quadratic function. And a degree 3 polynomial, meaning it contains an x cubed, is called a cubic. Now that we are introducing polynomials, we need to know the difference between a turning point and a point of inflection. A turning point forms a U-shape, like this red graph, where the gradient slowly reaches 0 and then goes back in the opposite direction. A point of inflection, as seen in the blue, is when the gradient hits 0, but then it keeps on going in the original direction. We can see the point of inflection at x equals -2 and y equals 0 in the cubic function. We can see the turning point of the quadratic in the red at x equals 2 and y equals 0. Note how the function flattens out and then reverses direction. Whilst a quadratic function can only have a turning point, a cubic function can either have a point of inflection or two turning points. Either way, it ends up continuing on in the same direction that it started. Sometimes a polynomial equation may appear in a form similar to the turning point form of a quadratic, but it's not possible to display all polynomials in this form, unlike a quadratic. This form is y equals a times x plus h all to the power of n plus k, and it lets us know where the turning point or point of inflection is straight away. If n is a positive odd integer equal to or greater than 3, then we know that the graph will have a point of inflection located at x equals -h and y equals k. If n is a positive even integer greater or equal to 2, then we know that the graph will have a turning point located at x equals -h and y equals k. To draw the rest of the graph, we go through the same process as the quadratic, setting x to 0 to calculate the y-intercept, and then y to 0 to calculate the x-intercept. For example, if we were required to sketch y equals 2 times x plus 1 all cubed plus 2, our first step would be locating our point of inflection. We know it has a point of inflection instead of a turning point because our n value is an odd number. And we know it is located at x equals -1 and y equals 2. Then we locate our y-intercept by setting x to 0, giving us 4, and we locate our x-intercept by setting y to 0, giving us -2. Now that we have the point of inflection and the intercepts, it's just a matter of connecting the dots in a polynomial shape, like so. Receiving a polynomial in turning point form is the easiest to sketch, as it will always be either the S shape of a cubic above when it is an odd number, or the U shape when n is an even number. However, since not all polynomials can be put in this form, they are not all this easy to sketch, but we'll cover them later. Until then, happy studying! Click here to go to the Engage wiki. Click here to go to the next video. Or, if you really want, you could just stare at this motivational poster.